Hello everyone. Today we're going to look at how to solve a system of linear inequalities. If you remember in Unit 1, we solved one inequality. Well, for systems, we're going to solve two or more inequalities together and look for the overlapping region. So how do you solve a system of linear inequalities? First, you have to make sure both equations or inequalities are in slope-intercept form. Remember, if you divide by a negative, you have to flip the inequality. Then you graph both equations on the same grid. Follow the slope, follow the y-intercept. You have to decide, is the line going to be a solid line or a dashed line? You're going to shade above the line or below the line. And then your answer is, where do both grids, lines, intersect? So if we remember that if we have a less than symbol, right, these are less than, these are greater than in this column. If we have a less than and a greater than symbol, those are dashed lines, like this. If we have an equals to, like less than or equals to or greater than or equals to, these are solid lines. So we will go ahead and connect the line, the dots. If our symbol is less than, we will shade below the line. So if here's our line, we will color below it. If our symbol is greater than, we will color above it, like this. Okay? So depending on where you are is what inequality you will use. So if I am a less than, that means I will be a dashed line and I should shade below. If I am a greater than or equal to, I would be a solid line shading above it. Okay? So hopefully that chart helps you out a little bit, or it helps you remember the information that you should already know. So moving down to example 1. It says y is less than negative 1/2 x plus 6, and y is greater than or equal to 3/4 x minus 4. We're going to graph these in two different colors. So if you're doing these notes at school or at home, I suggest using multiple colors to help you tell the difference between the two graphs. So for the first graph, I'm going to go ahead and use orange. If you notice, this equation is already in slope-intercept form. That means I have a slope of negative 1/2, and I have a y-intercept of 6. So on my graph, 1, 2, 3, 4, 5, 6 is where I start on the y-axis, not the x-axis. And then how do I move? I go down 1 to the right 2. So down 1, right 2, down 1, right 2. And I would want to continue that to fill up my whole graph. You can go in reverse and go up 1 and to the left 2. Now looking at your inequality, we have a less than inequality. So that should tell you that you need to shade below the line and that the line is dashed. So now when I go to connect these points, I should draw a dashed line. Make sure my arrows are on it. And then I'm going to color everywhere below this line. And I'm just going to do it very lightly because we have to put another graph on here. Okay. For my second equation, y is greater than or equal to 3/4 x minus 4. I'm going to go ahead and do this in pink. It's already y equals mx plus b. My slope is 3/4. My y-intercept is negative 4. So I'm going to start down at negative 4. And I'm going to go rise over run. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. And I'm going to fill up my graph. Now you should notice on this inequality, I'm greater than or equal to, so that means I'm a solid line, and I'm going to color above the line. So connecting these points, solid line, and now I'm going to color everywhere above the line. All right, so the intersection color. There's an answer to this problem, and we said the answer to this problem is, where do your two colors overlap? So if you notice, in this triangle right here is where I have my orange and my pink together. So an answer to this problem can only fall into that region. So for example, if I were going to name two solutions, I could pick points that are only in this green part, like 0, 0 is a solution. -3, 4 is a solution. So you want to pick points that are in the overlapping section. 2, 2 is a solution. Okay? What's not a solution? Any point outside of the shaded region. Like 9, -2 is not a solution. Why is it not a solution? It's not in the overlapping section. The point -1, 8 is not a solution because it's outside of the green triangle. Okay? Let's move on to example 2. Coming up here to example 2. The first graph that we want to do says x minus 3y is greater than 6. I'm going to solve this one in blue. However, this equation is not in slope-intercept form, so we need to solve for it. Minus x. So -3y is less than, remember we bring the right side down, we just turn it on its side. So -x plus 6. Divide everything by -3. And I get 1/3, positive 1/3 x minus 2. Now on this one, since we divided by negative right here, my less than inequality has to switch to a greater than. And that's only because we divided by a negative. Okay? So graphing this inequality means I have a slope of positive 1/3 and a y-intercept of -2. So up 1 over 3, up 1 over 3, or in reverse, down 1 and to the left 3. Since my inequality is now greater than, I know that's a dashed line, and I'm going to shade above, not solid, whoops. Dashed line colored above. Dashed line colored above. Okay. Next inequality. 3x plus 2y is less than or equal to 18. This one's not y equals mx plus b, so we have to solve it. Minus 3x. 2y is less than or equal to -3x plus 18. Divide by 2 gives me y is less than or equal to -3 over 2x plus 9. I do not have to flip the inequality on this one. I did not divide by a negative. So on this one, starting up at 9 for our y-intercept and our slope, -3 over 2, means we come down 3, positive 2. Down 3, positive 2. Since this is less than or equal to, I am a solid line, and I can color below the line. So solid line, shading below. Which means that my intersection color is where my red and my blue overlap. So that would be everything in this triangle, or this section of the graph. Okay? And my intersection color was yellow. So naming me two solutions to this point, this graph, I could say the point -6, -6,5 is the solution. I could say the point 1, 2, 3, 4, 1 is a solution. Any point in the section that overlaps. Okay? All right, last example. 4x plus 2y is less than 20 is not solved for y. So we minus 4x, minus 4x. 2y is less than negative 4x plus 20. Divide everything by 2. I do not have to switch the inequality sign. Gives me y is less than negative 2x plus 10, which means that I start this graph up at 10. If its slope is negative 2, remember that's negative 2 over 1, so I would go down to positive 1. Oops. Down to positive 1, down 2 over 1. Since it's less than, I have a dashed line, and I'm going to color below it. Now my other equation, y is less than negative 4. Since there's no x in my problem, if you remember Vuxhoy, if I just have a y, it's a horizontal line. So down at negative 4. And if I draw a horizontal line, I know it should be a dashed horizontal line. So I'm going to dash it this way. And it's less than, so I know I'm going to color below this line. So everywhere below the line. That means I have an intersection in this section right here. And naming two solutions could be any point where they overlap. So 0, negative 5 is a solution. 3, negative 10 is a solution. Because you name your points, remember x, y. So over on the x, how far up and down on the y? All right, so on the back of this notes sheet, there are 2 real-life problems. We will save those and do those together in class. Your secret word of the day is bananas. See you guys later.